The fundamental theorem of algebra states that every non-constant polynomial has at least one complex root. Consider a polynomial of degree n with complex coefficients. This theorem is crucial in various fields of mathematics and science. The theorem asserts that every non-constant polynomial can be factored into linear terms with complex roots. One way to prove the theorem involves using Liouville's theorem and the concept of analytic functions. Assume that f of z is a polynomial of degree n, with no roots in the complex plane. Using the triangle inequality, we can establish a lower bound for the absolute value of f of z. If f of z has no roots, then 1/f of z is analytic everywhere. By Liouville's theorem, a bounded analytic function is constant, which leads to a contradiction. The fundamental theorem of algebra has far-reaching implications in mathematics and science. For example, it guarantees that every polynomial equation has a solution in the complex numbers. The theorem has numerous applications in fields like physics, engineering, and computer science. It provides a powerful tool for solving polynomial equations and understanding the behavior of complex systems.